the furnaces do not rest. Not at midnight, not at dawn. Deep inside the Carnegie works, molten iron burns at nearly 3,000 degrees Fahrenheit, hotter than lava, brighter than anything the human eye should witness directly. The air itself shimmers. The floor vibrates beneath every footstep. On this shift, hundreds of men move through the casting floor in patterns worn smooth by repetition. Overhead cranes swing ladles of liquid iron from station to station. Sparks drift downward in slow orange arcs, settling on leather aprons, on concrete, on skin. Then comes the sound that a deep metallic crack rolls through the furnace hall. Workers pause. Steel mills groan and clang and rumble constantly. Strange noises are part of the work, absorbed into the body like a second heartbeat. The men return to their tasks. The crack returns. Louder at a seam along the furnace casing splits. Molten iron erupts outward in a blinding torrent, flooding the casting floor faster than a man can turn and run. Wood ignites on contact. Clothing vanishes in flame. The grease-slick floors that made every shift treacherous now seal the fate of men who slip trying to reach the exits. Some find the ladders. The molten river finds them first. Within seconds, the furnace hall is an inferno. Machinery collapses inward. The blast rattles windows across the surrounding town, waking families who already know better than to take comfort in that sound. When the fires cool, dozens of workers are dead. Some bodies are never recovered. Inside Carnegie's steel empire, this is not the first disaster. Company records already hold other names, other shifts, other furnaces that gave way. It will not be the last. Steel does not merely support the nation, it defines it. Railroads push west across open plains. Bridges carry commerce over rivers that once stopped everything. Cities grow upward, their iron skeletons rising story by story against the sky. Andrew Carnegie understands this hunger before nearly anyone else. His mills in western Pennsylvania operate on a scale the world has not seen. Blast furnaces tower over the riverbanks. Rail yards groan under continuous shipments of ore and coal. The smell of sulfur and burning coke hangs over entire towns. The numbers reflect the era's appetite. In 1870, the United States produces fewer than 1 million tons of steel annually. By the early 1900s, that figure surpasses 10 million. The mills do not pause to absorb the change. They accelerate into it. Furnaces run for months without shutdown. Production schedules treat delay as failure. Speed becomes not a preference but a mandate handed down from ownership to foremen to the men on the floor. Those men work 12-hour shifts inside heat that regularly exceeds 120 degrees Fahrenheit near the furnace mouth. The air tastes of iron and ash. Sweat evaporates before it can cool the skin. Their protection against metal that can melt rock consists of a leather apron, wool clothing, sometimes a pair of gloves. For many of these workers, immigrants who arrive with little and find the mills waiting, the wages justify the risk. Steel pays better than most work available to new arrivals. Entire neighborhoods build their existence around the mill gates. They have no power to demand better. And ownership has no legal obligation to provide it. The conditions are not a secret. They are a policy. It stands like an iron cathedral, and it never goes cold. The blast furnace towers over the factory floor, its outer shell radiating heat that a man feels in his chest before he comes within 30 feet of it. Raw materials feed continuously into the top, iron or coke, limestone, descending through temperatures that climb beyond 2,900 degrees Fahrenheit before they emerge transformed. The chemistry is straightforward. Forced air drives combustion intense enough to strip oxygen from iron ore. The resulting liquid metal sinks to the base of the furnace, collecting in a glowing reservoir that pulses with its own slow, terrible light. Workers release it in controlled streams into ladles capable of holding more than 100 tons at a time. Overhead cranes lift these containers and carry them across the casting floor, suspended above the men working below. Everything depends on precision. Every valve, every crane, every pour, but the furnace cannot stop. Cooling a blast furnace too quickly cracks the internal lining and destroys the structure itself. So the system runs continuously, day after day, month after month, year after year. Maintenance cannot wait for a safe moment, because no safe moment exists. Workers inspect valves and repair machinery with liquid iron burning only feet away, the glow washing their faces orange, the heat pressing against their skin like a physical weight. Beneath the controlled surface, enormous forces push constantly against steel walls, pipes, and seams. Pressure accumulates. Metal fatigues. Stress fractures form in places no inspection reaches. The furnace does not announce when something is about to give way, it simply does. Steel does not simply endure heat, it is slowly consumed by it. Every cycle of extreme temperature causes the furnace shell to expand and contract, and over months of continuous operation, that movement opens microscopic fractures inside the metal and brick. They are invisible from the outside. They grow in silence, behind layers of casing that no inspection reaches while the furnace remains active. Inside, the molten iron itself accelerates the damage. Liquid metal erodes the protective refractory lining designed to shield the outer structure from direct heat exposure. As that lining thins, heat penetrates deeper. Eventually it reaches the steel casing. The outer wall begins to weaken from within. Some workers notice the signs before engineers record them formally. A section of outer casing glows faintly red where it should remain dark. A deep creak travels through the furnace shell during tapping operations. Metal that should feel merely hot becomes untouchable. These are not mysteries to the men working beside the furnace daily. They are warnings, recognized and discussed quietly among themselves. Engineers file reports. Supervisors acknowledge the concerns. But shutting down a furnace for repairs means halting production, and halting production means breaking contract schedules that carry financial consequences ownership refuses to absorb. Temporary patches replace structural repairs. Known problems are managed rather than solved. The workers beside those furnaces understand what the delay means. Refusing the assignment means losing the job, and losing the job means losing the wages that keep families housed and fed. The choice is not between safety and risk. It is between certain loss now and uncertain catastrophe later. History records which option they were left with. The disasters do not arrive without pattern, they arrive with regularity. Across Pennsylvania, Ohio, and the industrial corridors stretching between them, the mills are killing workers at a pace that engineering journals track in careful, bloodless language while the public reads about new bridges and taller skylines. In Pennsylvania, a furnace rupture releases molten iron across a casting floor without warning. The metal moves faster than men can clear its path. Dozens die. In Ohio, a crane cable carrying a full ladle of liquid steel fails mid-transit. The container strikes the ground and erupts outward, spraying metal across the floor in every direction. In rolling mills, steam boilers operating under extreme pressure detonate when metal fatigue finally splits their shells. The force does not merely damage the surrounding structure, it flattens it. Walls buckle. Roofs fold inward. Workers are thrown through the air by the concussive wave before the heat reaches them. The technical explanation is consistent across each incident. Furnaces pushed beyond designed operating limits. Maintenance intervals shortened to preserve production schedules. Metal stressed past the point where inspection might have caught the failure. Engineering reports document the pattern with precision, circulate within industry publications, and proceed no further outside the mill gates. Steel remains the symbol of national progress. Railroads push into new territory. Cities rise on iron frames. The demand does not pause to account for what the production costs. Inside the gates, the workers carrying that cost understand something the progress narrative omits. The next failure is not a possibility to be weighed and managed. IT is already building somewhere in the system. The mill and the neighborhood are not separate worlds. They are the same world, divided only by a fence line. Near Pittsburgh and across the industrial valleys of Pennsylvania, rows of worker housing rise within sight of furnace smokestacks. At night, the sky above these streets glows a dull, persistent orange, light thrown upward by molten metal pouring across casting floors a quarter-mile away. The ground beneath the houses trembles when the heaviest machinery cycles. Children grow up knowing that vibration the way other children know birdsong. The mills draw people across oceans. Immigrant families arrive from Poland, Hungary, Slovakia, and Italy, drawn by steel wages that exceed anything available in the economies they left behind. Entire communities organize themselves around the mill gates, boarding houses, churches, shops, schools, all dependent on the rhythm of production schedules they have no power to influence. Most workers live minutes from their stations. When the system fails, the distance between disaster and home is almost nothing. Church bells mark the funerals in clusters. Widows appear at company offices to ask about compensation that rarely comes in meaningful amounts. Children old enough to understand begin calculating how many years before they, too, can take a position inside the furnace hall. The community grieves and then returns to work, because the alternative, the mill closing, the wages stopping, carries its own form of devastation. So the neighborhood learns to live beside machinery capable of killing dozens in a single failure. Most shifts end without catastrophe. Most nights the orange glow means only that production continues. But when the system finally breaks, it does not break only inside the factory walls. No alarm sounds first. No warning reaches the casting floor before the furnace wall gives way. Months of thermal stress have worked silently through the steel shell, expanding and contracting the metal through thousands of heat cycles until the fractures inside it connect and deepen beyond the point of holding. The protective brick lining that separates molten iron from the outer casing has thinned to almost nothing. The pressure inside the furnace has nowhere left to go. During a routine tapping operation, a procedure these men have performed hundreds of times, the weakened casing fails. The rupture is instantaneous. Thousands of pounds of liquid iron erupt outward through the breach, crossing the casting floor in seconds. The men stationed nearest the furnace face heat so concentrated that clothing ignites before the metal reaches them. Those slightly further away turn toward the sound and find the iron already moving around the bases of machines they cannot climb or move. Some workers reach for stairways. Others run deeper into the mill to pull co-workers back from the advancing flow. The casting channels designed to direct controlled pours are overwhelmed within moments. The volume released is beyond anything the drainage system was built to manage. Then the secondary explosions begin. Molten iron contacts the water lines running through the floor and walls to cool equipment. Water converts to steam faster than the pipes can vent it. The pressure tears through metal and masonry with a percussive force that shakes the entire structure. Cranes destabilize and fall. Roof beams crack and buckle downward. In less than 60 seconds, the furnace hall ceases to function as a workplace. It becomes something else entirely. The fire does not stay where the rupture began. Demoose. Molten iron flowing across the casting floor reaches the wooden platforms built alongside machinery, and they ignite as though they were paper. Grease packed into equipment joints, oil pooled beneath crane mechanisms, lubricants coating every moving surface, all of it becomes fuel. The flames climb the internal structure of the mill and find new material at every level. Workers in departments separated from the furnace hall by walls and distance hear the initial blast as a single concussive thud. Some mistake it for a dropped ladle or a burst steam line. They move toward corridors to investigate. Smoke reaches them before any explanation does, black and thick, filling stairwells and narrowing the usable air to a band near the floor. Many never learn what caused the disaster before they are fighting simply to find a way out. Outside the mill gates, the neighborhood already knows something has gone wrong. The glow above the factory rises higher and brighter than the ordinary orange cast of night production. Windows crack in the closest streets from the shockwave. Residents stand in doorways watching the sky. Firefighters arrive and find the heat pushing them back before they reach the building's perimeter. Water directed onto pools of burning metal converts instantly to scalding steam, turning each attempted approach into a secondary hazard. The tools available are inadequate for what they are facing. Rescue crews move toward the outer edges of the structure searching for survivors. Entire sections of the floor have already hardened beneath cooling iron. Some men are still inside those sections. They arrive before the fires are fully out. Wives, mothers, older children, standing in the early morning cold outside gates that will not open for them, watching smoke still rising from the structure beyond. Some already know. Others hold onto the possibility that their husband, their father, their brother, made it out through a different exit and simply has not yet found a way to send word. Company officials move through the grounds with ledgers, assembling lists of the missing from shift records and the accounts of survivors. The numbers climb through the morning and do not stop climbing. By afternoon, dozens of deaths are confirmed. Others remain designated as missing, a category that offers families nothing except the agony of continued uncertainty. The recovery effort proceeds under conditions that defeat conventional methods. In sections of the furnace hall where the iron pooled deepest before cooling, the heat generated during those hours has left nothing recoverable. The metal encases what it reached. Teams work the outer areas, extracting men who died trying to reach exits, who died warning others, who died because the building's layout offered no path clear of the flow. The dead are disproportionately immigrant laborers, men from Poland, Hungary, Slovakia, Italy, who came to Pennsylvania for wages that promised stability and found instead an industry that consumed them. Some arrived in America within the past year. Some leave behind 4 or 5 children. Some leave behind families who do not yet speak enough English to navigate what comes next. Entire shifts are gone. The community does not have enough time to finish grieving one loss before the next name is confirmed. The investigation begins in the wreckage before the metal has fully cooled. Engineers pick through collapsed beams and hardened iron, documenting the point of failure with technical precision. Their findings, when published, are accurate as far as they reach. A section of the furnace shell, weakened by thermal stress and inadequate maintenance, ruptured under operating pressure. The mechanical sequence is established. The immediate cause is named. The inquiry stops there. The questions that follow from those findings receive no equivalent scrutiny. Why was this furnace operating at full capacity when sections of its casing showed visible signs of stress fatigue? Why did internal reports noting the deterioration not produce a shutdown order? Who reviewed those reports, and what decision was made afterward? The paper trail exists. The engineering journals contain it. But no formal process compels the company to answer for the distance between what was known and what was done. The repairs begin within weeks. Damaged sections of the furnace shell are replaced. New brick lining is installed. The structural work is completed efficiently, driven by the same production timeline that drove the conditions preceding the disaster. The mill cannot afford an extended closure, and it does not take one that within months, the rebuilt furnace returns to full operation. New workers, some of them recent arrivals with no knowledge of what occurred on that floor, take their positions beside it. The shift foreman walks the same casting floor. The overhead cranes resume their circuits. The maintenance schedules that shortened inspection intervals remain in place. The production targets that made delay unacceptable remain in place. The furnace runs. The system that broke it runs with it. The orders do not stop arriving. Railroads expanding across new territories require steel by the trainload. Construction companies erecting steel-framed buildings in every major city place contracts months in advance. Shipbuilders, bridge engineers, municipal governments, all of them need metal, need it continuously, and need it on schedule. The industrial appetite of the late 19th century is enormous, and the mills that feed it operate under pressure that flows directly from the boardroom down to the casting floor. Halting production to address structural problems carries a cost that company ledgers make visible immediately. Lost output, broken contracts, idle furnaces that still consume resources while generating nothing. Every hour of shutdown translates into a financial consequence that ownership weighs against the alternative. The alternative is allowing known problems to persist a little longer, patching what can be patched, running the furnace through another cycle and then another, until the decision is no longer available to make. The workers who stand beside those furnaces do not make this calculation. It is made for them. Many are recent immigrants who arrived in Pennsylvania, Ohio, and Illinois with few resources and no established connections to other industries. Steel wages are not exceptional out of generosity, they reflect the conditions under which the work is performed. Men accept those conditions because refusing them means losing the position entirely, and losing the position means losing the income that keeps their families housed through the winter. They are not reckless. They are not uninformed. They understand precisely what surrounds them on every shift. They simply have no mechanism to demand anything different. The steel continues pouring. The casualties accumulate alongside it. Change comes, but it comes slowly, and it comes late. Labor organizers who have spent years absorbing the cost of unsafe conditions in their own bodies begin building movements large enough to compel attention. Workers demand shorter shifts, basic protective equipment, and the legal right to refuse assignments on machinery showing signs of imminent failure. Investigative journalists document the death tolls that company reports minimize. State governments, pressed by constituencies that include the families of the dead, begin drafting industrial safety regulations with actual enforcement mechanisms behind them. The conditions inside the mills gradually improve. Inspection schedules are formalized. Protective standards are codified. The furnaces do not become safe, but they become measurably less lethal than they were in the decades when no external authority required anything of the men who owned them. None of this reaches the workers who did not survive to see it. The bridges carrying daily traffic across American rivers were framed with steel poured in those early mills. The railroads that connected the continent ran on rails produced in furnace halls where men worked 12-hour shifts in heat that exceeded every reasonable limit. The skyscrapers that define